In this section, we're going to explore how elementary row operations on a matrix affect the determinant of that matrix. So let's consider a simple example just to get a feel for it. Let's consider the identity matrix I3, and I'm going to use this matrix because it's real easy to find the determinant of the identity matrix, right? It's a triangular matrix. And so I just need to multiply the entries along the main diagonal. So determinant of the identity matrix is just 1 times 1 times 1, which is just 1. Okay? Now what I want to do is I want to look at each elementary row operation in turn. So one elementary row operation is we could swap two rows. So say I swap row 2 and row 3. So row 1 stays the same. My new row 2 is my old row 3. And my new row 3 is my old row 2. Okay, so that's my matrix. Let's find the determinant of this. Okay, and let's call this matrix A. So matrix A now is no longer a triangular matrix, but it's still pretty easy to take the determinant of this matrix. I could expand, for example, along the first row. Got a lot of zeros there. So I've got 1 times, and then I take the determinant of what's left over after canceling the row and column. I'd get 0 minus 1. So I'd get 1, this 1, times 0 minus 1. That's going to be a negative 1. Okay, so it looks like swapping the two rows, it just changed my determinant from 1 to negative 1. It swapped the sign, right? Okay, let's see what happens if I do a different elementary row operation. Let's take the identity matrix and multiply row 2 by a non-zero constant. So let's say I take one of the rows, say row 2, and let's multiply it by 3. That'll be my new row 2. Okay? So after doing this elementary row operation, row 2 becomes 0, 3, 0. The other two rows stay the same. We'll call this matrix B. Okay? Determinant of matrix B, really easy to find because it is a triangular matrix, right? And so all I have to do is multiply the entries along the main diagonal. So 1 times 3 times 1 is 3. Okay? So multiplying one of the rows by a non-zero constant, it just multiplied the determinant by that much. I multiplied one of my rows by 3. My new determinant is 3 times as much as the original determinant. Okay. Got one more elementary row operation. Let's say I take twice row 1. I'm going to add it to row 3. That'll be my new row 3. Okay, so we're exploring what happens if I add a multiple of one row to another row. So the only row changing here is row 3. So row 1 and row 2 stay the same. Row 3, I'm going to get twice row 1 plus row 3, so I'll get 2, 0, 1 is my new row 3. Let's call this matrix C. What's the determinant of matrix C? Well, matrix C is still a triangular matrix. It's lower triangular, right? And so I could just multiply the entries along the main diagonal. 1 times 1 times 1 is 1. So for this last elementary row operation, I started with my original matrix, had a determinant of 1, and then after applying this particular elementary row operation, the resultant matrix has a determinant of 1 also. So the elementary row operation didn't actually change the determinant at all. So these observations that we made that apply to the identity matrix, these observations actually apply to any elementary row operations on any square matrix and how they change the determinant. Okay? And so we have the following results. So let's let A be a square matrix, an n by n matrix, if B is obtained from A by interchanging two different rows. So if I take one row and swap it with another row, then the determinant of the resulting matrix swap signs from the determinant of the original matrix. Okay, just swap signs, and that's what we saw here. The determinant of our original matrix is 1. When we swap two rows, the determinant of the altered matrix swapped signs. Okay? If matrix B is obtained from the original matrix A by multiplying one of the rows of A by a non-zero constant, then the determinant of the new matrix is the constant times the determinant of the old matrix. So the row operation we're doing here is if we take a non-zero constant times one of the rows, and that's replaces the row, so I'm multiplying the row by a non-zero constant. Then the new determinant is the constant times the old determinant. Again, that's what we saw here. Our original determinant was 1. We took row 2, we multiplied it by a non-zero constant, 3. And so the determinant of the resulting matrix was 3, which is 3 times the determinant of our original matrix. Okay? And finally, the last elementary row operation, if we obtain matrix B from my original matrix A by adding a multiple of one row of A to another row, so that would be a multiple of, taking a multiple of one row and adding it to another row, okay, then the determinant doesn't change at all. The determinant of my new matrix and the determinant of my old matrix are exactly the same. And that's what we saw here. Determinant of the original identity matrix was 1. I took twice row 1, I added it to row 3. That was my new row 3. The determinant of the resulting matrix did not change at all. Okay? Now, we're not going to prove these formally. The proof is rather tedious and not all that important that you know exactly. But if you want to, the proof is in your textbook. But it is important that you understand how elementary row operations will affect the determinant of the resultant matrix.